This is Dr. Sridhar back to you with another network theorem, that is reciprocity theorem. As we all know that this theorem is highly useful in electromagnetic circuits, especially at transmitters and receivers in the magnetic circuits, or especially in the antennas and wave propagation, receivers and transmitters. That is the field where this reciprocity theorem is highly benefited for the electrical and electronics engineers. So what is this reciprocity theorem? Let us talk about this reciprocity theorem with some simple statements and with the broad idea of presenting one simple problem. This problem I am presenting for better understanding of this reciprocity theorem. So basically, let us start this reciprocity theorem with the statement. So the statement of this reciprocity theorem is the value of the current due to single source in any particular branch of circuit is equal to the value of current in the original branch where the source was placed when the source is shifted to that particular branch of circuit. Okay. Now, you might have confused if I would narrate so many things by just statements. So, in order to overcome this, I am presenting the structure also. So, with the help of this simple electrical circuit, let us examine what is this reciprocity theorem and how the sources will be transferred. If the sources are transferred, what will be the consequences of transferring the sources from one side of the circuit to the another side of the same circuit. So, let me take this simple example, 10 volts and having multiple number of resistors, and this 10 volts is nothing but this is an active source, right? Now, what is our interest? Now, my point of interest is nothing but the 3 ohm. So, this 10 volts voltage source will have some response at this 3 ohm resistor. So, what is this theorem? Okay, this 10 volts voltage source, if it is connected in this electrical circuit, definitely this 10 volt will create, or you can see the response of this 10 volts at 3 ohm resistor. Yes, right. Now, similarly, if this 10 volts is shifted from this side to this side, here if we could place at 3 ohm point, then the response will be the same even at 2 ohm resistance point. That's what our reciprocity theorem is going to explain. Now, see, that's the same thing. Let us examine with some animation kind of things. Now, in the first case, this 10 volts will create some response, or this 10 volts will have some response, and the response is nothing but the I. Now, I am going to examine the performance or this 10 volts in 3 ohm resistor. So, that current is nothing but I. So, what is this I? I is nothing but this is the response at 3 ohm resistor because of this 10 volt source. If 10 volt is active in the electrical circuit, now this 10 volt may drive some amount of current to this particular junction. Here this current may be divided into the two parallel paths. How much of current it is coming into the second loop? That is nothing but that is the response of this 10 volt source, and I am going to examine the response at 3 ohm resistor, which is nothing but the current I. This is about the first circuit. Now, if you are going back to the second circuit, now I have shifted this 10 volt voltage source from this point to this response what we examined in the first circuit. So, now see, this 10 volts as it is, we have shifted to the point where we have studied or we have examined the response in the first case. So, we have examined the response here across this terminal. So, I have shifted this 10 volts directly the voltage source from this point to this point. Now, as it is in the second one. Now, what you have to examine now? If the voltage source is shifted to this point, then the current here, that is nothing but where the voltage was there, where the voltage source was there, that is nothing but the I1 current. Now, you have to see that whether this I is nothing but I1 both are same or not. If I and I1 both are same, then that is nothing but the statement for the reciprocity theorem. So, we will examine by solving one simple problem whether this I and I1s are same or not. If I and I1s are same, then that is the verification for reciprocity theorem. If this given circuit is having reciprocity property, then this I and I1 must and should be same. Otherwise, the circuit could be said that this circuit is not having reciprocity property. So once again, I am just conclusion of this reciprocity theorem is, if voltage source is shifted between cause and responses, then cause and responses can be interchanged. So this is the cause for this response in the first circuit. Then I have interchanged the cause and response terminals, that input and output terminals, then the response should be same. That is the case here. So if the voltage source is shifted from this point to this point, like in the second circuit, then the response at the first point motion should be same. That is nothing but the I. So don't confuse with those so much of analysis. Just let us go back to the one simple problem. This problem most probably help us for understanding what the reciprocity theorem, how the voltage sources will be shifted, how we are going to calculate the responses. Just wait. So in order to verify this theorem, I and I1 motion should be same. So here sometimes people may ask, what about the transfer resistance? The transfer resistance means this is V by I is nothing but the transfer resistance. So what is this transfer resistance? Transfer resistance means the total equivalent of that circuit. If the transfer resistance is same, then only this interchanging of the sources will holds good. Otherwise, the circuit won't have the reciprocity property. So just verification of the reciprocity theorem can be done. Now, suppose if the circuit, what is the circuit we have taken is 10 volts, 2 ohm resistor, 4 ohm resistor, 5 ohm resistor, 6 ohm and 3 ohm. So first, let me calculate what is this current I in the first circuit. And again, once this 10 volts source is shifted to the response point, the point at which we have calculated the response, if we are shifting that voltage source, that is nothing but the input or cause, to the response point, then at the cause point means at the input terminal, let me calculate the current I1. It is very simple. Just make use of the fundamental principles, that is either KVL or mesh analysis or whatever it may be. This will solve our problem here. Now let me check this 10 volts and this is nothing but one mesh, and this is a second mesh. That second mesh is nothing but this, and let me calculate what are the currents here. Now this current is nothing but in the first mesh that current is IA. In the second mesh, anyhow this current is required, so I am directly taking this current as I, because this is the same response at 3 ohm point or at the output terminals. At this point the current is nothing but I, so let me assume the current in the second loop as I only. So first loop current is nothing but the IA current. So after earmarking the currents along with the directions, let us calculate what are the drops across various elements. So across 4 ohm resistor, the drop is nothing but the 4 into IA, and across 5 ohm resistor, the drop is nothing but the 5 into IA minus I, because both the currents are traveling in the opposing directions through this 5 ohm resistor. So the drop across this 5 ohm resistor is 5 into IA minus I, and anyhow through this 2 ohm resistor, the drop is nothing but, or across the 2 ohm resistor, the drop is 2 times of IA. So the sum of these voltage drops is equal to 10 volts. So the drop, if you are simplifying that voltage balance equation, that could be IA into 11 minus 5 times of I is nothing but the input voltage source, that is 10 volts. So 11 IA minus 5 I is equal to 10. Similarly, let us calculate the voltage balance equation in the second loop. The drop across this 5 ohm resistor is 5 times of I minus IA, and the drop across 6 ohm, because it is not a shared element, so only the response through this is nothing but I only, so 6 times of I. Similarly, through this 3 ohm, that is nothing but the 3 times of I. Now the voltage balance equation is minus 5 times of I1 plus 14 times of I is nothing but 0, because there is no active voltage source in the second mesh. Now if we are simplifying this voltage balance equation of mesh 1 and mesh 2, we can achieve whatever the IA value and whatever the I value. So IA is equal to 1.085 amps and I is equal to 0.387 amps. So what is this I is equal to 0.387 amps means? So this is a response at 3 ohm point or at this particular portion because of this 10 volts. So if this 10 volts is applied to the circuit, applied to this given circuit, then the response at this particular point is nothing but 0.387 amps. So this is about this is the description of the first circuit. So okay, so in this circuit we have calculated mesh currents and whatever the loop current, first loop, second loop, and the desired point where we are going to apply the reciprocity theorem. So that is nothing but we have earmarked where we are going to examine the output. So that is the point here. So this green colored arrow mark represents response due to response of this 10 volt source. So this is the input and this is nothing but output. Output also we have calculated, that is I is equal to 0.387 amps. Right. This is the complete analysis of the first circuit. So here, after getting this information, I want to ensure whether this given circuit is holding this reciprocity properties or not. Now, how can we do that? Only the thing is, you have to interchange the input and output terminals. In the simplest way, we can say that if the input and output terminals get shifted, then after shifting this, we have to verify whether this circuit is having reciprocity properties or not. That's, we can do it. Now just shift input and output terminals. So this is in the basic circuit, these are nothing but the output terminals and this is nothing but the input terminal. Just interchange the input and output elements. So output is shifted to the input in the second circuit and input is shifted to the output in the second circuit. The 10 volt is connected like this, because see here, you are not supposed to change the direction of either current responses or the voltage sources. That precaution you have to take. Otherwise, what happens? Nothing is wrong, but we can see some negative responses. That's only the problem. Otherwise, everything will be same. So 10 volts is shifted to the output terminals and response I am going to calculate at the input terminals. Just after getting this, after shifting the input and output terminals vice versa, just again apply the KVL to the first loop and KVL for the second loop. So here the current is nothing but, say the current is in the reverse direction without changing this I1's property. That is one of the important thing you have to observe. So I1 is nothing but it is anti-clockwise direction. Otherwise, we are habituated to take a clockwise direction. Even though if we are taking in the first circuit, the loops we have taken in the clockwise. The currents, the mesh currents we are habituated to take in the clockwise direction. Now in this case, without losing generosity, I don't want to see. I want to apply the current. I want to determine this current in the first loop of the second circuit in the same direction what we are expecting. So this current is nothing but I1 is like this. So let me take anti-clockwise direction mesh current in the first loop of the second circuit as shown in the figure here. So this is about this. And second one also, okay, let me take here also anti-clockwise direction. Now no matter, you can take in the clockwise also, no matter here. But anyhow, upper plate is positive of this voltage source. Let me take positive and negative. So anti-clockwise direction in the second loop also. So this is IB is earmark and this is nothing but the I1. So after identifying, after choosing these current directions of the mesh currents, then you apply Kirchhoff voltage law. So drop across this 4 ohm is as usually 4 times of I1, 2 times of I1 across this 2 ohm resistor, and this across this 5 ohm, this current directions are important here, 5 times of I1, and this is in opposite direction. So 5 times of I1 minus IB, and there is no active voltage source in the first loop, so it is becomes 0. So that expression, the voltage balance expression is minus 5 times of IB plus 11 times of I1 is equal to 0. Similarly, apply the Kirchhoff voltage law for the second loop of the second circuit. So drop across the 6 ohm is nothing but the 6 times of IB. Drop across 3 ohm is 3 times of IB. Drop across 5 ohm is 5 times of IB minus I1. So that is the small difference, because this 5 ohm is shared by 2 loops here, first loop and second loop. So that's why in which loop you are working, you try to give that respective loop current as a positive and other currents based on the directions. Whether it is in the same direction, take it as positive, or in the opposite direction, consider that current as a negative current. So the voltage balance equation of second loop is So 14 IB minus 5 times of I1 is equal to active voltage source value is 10. So let us simplify the voltage balance equations of first loop and second loop. Then the values are I1 is equal to 0.387 amps and IB is equal to 0.852 amps. Now, after this, we have to examine whether the value of the response in the first circuit, this value, and the value of the response after shifting the voltage source to the output terminals, the value of I1. So these two values we have to compare. Now here the I is nothing but 0.387 amps. Here also I1 is equal to 0.387 amps. Both are same. Hence the reciprocity theorem is proved. So this circuit is holding the reciprocity properties. So the resistance, the transfer resistance also you can calculate. So if it is required, that can also be calculated. That is 25.83 ohms. That is a voltage. That is 10 V. That is a voltage divided by the reciprocity current. So that value is nothing but the 0.387. So the total resistance is nothing but the 25.83 ohm. So these type of circuits are very helpful in the transmitter and receiver. If the transmitter is just shifted to the receiver point and receiver is shifted to the transmitter point, especially in electromagnetic circuits, this theorem is very, very beneficial for engineers. So in view of that, in order to meet that particular applications, this reciprocity theorem has been proposed and explained. I hope you understood very well with this simple example. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.